Hello, and a very warm welcome to everyone joining us from around the world. My name is Bhumi Shah, conference producer at Media Fusion, and I am delighted to host this important conversation today. The global composite market is accelerating towards a projected $158 billion by 2030, fueled by surging demand across automotive, aerospace, and renewable energy sectors, with a robust CAGR of 7.9% from 2024 to 2030. In the Middle East region alone, the rapid infrastructure development and increased focus on manufacturing is accelerating the demand for composites and other materials. It is with this in mind that Media Fusion and Crane Communication established the first Middle East Composites and Advanced Materials Expo in 2023. Today's webinar is a special pre-event session leading up to this flagship gathering, the third edition of which will take place in collaboration with the UAE Ministry of Energy and Infrastructure from 15th to 17th of September at the Dubai World Trade Center. Mecam Expo is the region's premier platform for composites and advanced materials, bringing together the full composites value chain from raw materials, equipment, and tools to intermediate products, engineering, and research and development for a truly comprehensive experience, including an exhibition and a showcase and a high level conference. Attendees include manufacturers, suppliers, distributors, and solution providers across composites, raw materials, and advanced technologies. If you are interested in participating in the event, please feel free to connect with our team at the end of this webinar. Our downloadable brochure has been inserted into the handout section of your screen. Now, let's turn to the theme of today's session. Next is now. What's powering the next frontier in composites and advanced materials? At the heart of today's discussion is a powerful and timely question. What is next? What breakthroughs are shaping the future of composites and advanced materials? Which technologies, market shifts, and applications are redefining the sectors from aerospace and automotive to energy to electronics and beyond? We are truly at a turning point in material science. Climate urgency, digital acceleration, and rising performance demands are reshaping what's possible. Composites and advanced materials are no longer future concepts. They are the critical enablers of smarter, lighter, stronger, and more sustainable solutions today. From aircraft and wind turbines to EVs, electronics to medical devices. So, we have also set aside time for questions and answers. So, please feel free to drop your thoughts or questions into the Q&A or chat box as we go. Thank you once again for joining us. Let's dive into today's discussion. Now, I have the pleasure of introducing our moderator, Mr. Chandranath Chatterjee, who will guide today's discussion. A mechanical engineer with a PG diploma in business management, he brings over 40 years of industry experience, including 25 plus years in president or CEO roles across manufacturing, technology transfer, and greenfield project leadership. Currently a Dubai-based C-suite consultant, he remains actively engaged in the global composites industry for the past 2 decades through strategic advisory, trade forums, and technical reach out. And joining the panel are four incredible experts helping push the boundaries of what materials can do. Mr. Pascal Gallo, CEO and co-founder, PhD Composites Recycling. With a PhD in physics and a background in engineering, he brings deep expertise in sustainable innovation and circular economy solutions for hard to recycle materials. Welcome, Mr. Pascal. Next, we have Mr. Gary Owen, CEO, Lineat Composites Limited. With over 25 years in material development and sustainability, he brings deep experience across marine, aerospace, and automotive sectors and is transforming the future of recycled carbon fiber. Welcome, Mr. Gary Owen. Next, we have Mr. Paolo Dassi. He is industry and mass transportation consultant for Bcomp Limited, an aerospace engineer specialized in lightweight structures and composites. He has led innovations across industries from racing yachts to architecture while championing manufacturability in design. Welcome, Mr. Paolo. Along with him, we have Mr. Murad Muntasir, co-founder CRP Gulf. Him being the co-founder of the UAE's first composite 3D printing service using SLS technology, has successfully built the business from the ground up for team, supply chain, marketing, and regional outreach included. Welcome, Mr. Murad. These panelists bring perspectives from across the innovation pipeline, research, manufacturing, product development, and commercialization. A very warm welcome to all of you. And now over to you, Mr. Chatterjee.
Thank you, Bhumi. Uh, Good afternoon and good evening, everyone. At the outset, I would like to welcome our esteemed panelist speakers and also the attendees who have joined us today for this very interesting topic of what is powering the next frontier in composites and advanced material. My name is Chandranath Chatterjee, as introduced by Bhumi, and I'm privileged to be the moderator for today's webinar session. It's indeed a pleasure and honor to host this august gathering of professionals, researchers, industry leaders who are working at the forefront of material innovation and sustainability for a better tomorrow for all of us. Friends, as we all know, advanced composites are becoming the next generation backbone of engineering. Now, from aerospace to automotive to infrastructure to energy, all across. And with growing usage comes, to my mind, a very growing responsibility. Uh, Today's discussion, we will explore how collaborative research and development, proactive regulatory alignment, recycling, reusage, circular economy, and the understanding of how consumer-driven sustainability trends are shaping the future of today's composites. We will hear the insights from experts on emerging technology, policy framework, and how industries are adapting, not just in terms of performance, but also environmental and social responsibility. I request everyone, the attendees mainly, to stay engaged, share your questions in the chat box, and make the most of the question and answer session, which we plan to have at the end of the panel discussion. We will try our best to accommodate as many questions as possible. But given the paucity of time, in case we are missing out someone, please do excuse us for the same. In today's webinar, as we said or described by Bhumi, we will be broadly discussing, not exactly in the chronological order which I am expressing, about achieving sustainability goals through material innovation, market shifts, shaping demand for composites, critical role of cross-industry collaboration and research for advanced materials, the importance of advanced recycling and reuse of composites for a circular and sustainable future, and lastly, R&D collaboration and regulatory readiness. So, to start with, I would like to invite Mr. Paolo Dassi. Paolo, can you briefly, first of all, explain to our attendees, for who are not very much aware about composites, what are advanced composites and how do they differ from the conventional composites?
Yeah. So I always start with a very rough comparisons. Even a bathtub is made out of composites, and even a Boeing 787 airplane is made out of composites. So in between, we
Precisely.
have a variety of processes, materials, requirements that are defined by the object we are willing to make. We refer usually to advanced composites. We're referring to composites that are usually long fibers, which means that have a good mechanical performance. They have a high thermal stability. So typically looking at pre-preg processes or infusion with epoxy resin processes. And in terms of general design, we are usually looking at sandwich structures as opposed to monolithic structures. So basically, we are referring to advanced composites where we are not only looking for high mechanical performance, but we are also introducing other variables such as lightweighting or fire resistance or stability in the dimensions or any other particular property that the component has to have to achieve the objectives it is built for. And
For my understanding, can we say that these advanced composites can also have tailored properties in them, if so required?
sorry,
When I
they
say
can have
tailored property, when I say tailored properties means to a specific requirement, you
tailored.
can
Yes, of
formulate in
course.
such a way that you
Yes,
use a tailored
absolutely.
property. It is possible to do
Absolutely,
that, isn't it?
absolutely, and this is
Okay,
something that
very good.
usually in very advanced projects is achieved not only by one company or one team, but it needs the interaction between all the stakeholders of the supply chain starting from engineers and designers, structural engineers, manufacturers, mold manufacturers, material developers, and so on, because composite materials are, let's say, made when you are making the parts. So it's not like a steel beam that is bought in its ultimate shape. But composites can be tailored and make and tailored to the properties they need to fulfill during the manufacturing of the parts. So it is essential that all the people involved in the development of a project are involved from the very early phases to get the most out of the materials.
Wonderful. And how do these advanced composites contribute to achieving the global sustainability goals?
Yeah.
How do they
So
help you?
the first topic is lightweighting. So as you can imagine, especially if you are looking at components that need energy to be moved, namely car, buses, trucks, trains, and even more so airplanes. Every gram saved means less energy required to move the part, which means less pollution, which multiplied by 25, 30 years of lifespan of the component leads to incredibly big savings in terms of emissions in the atmosphere. The other topic that has to be accounted for is the end of life of the components and the pollution created while making the material. For example, we know that there are different fibers available in the market. More traditional ones like glass, carbon, or aramid, but also nowadays we have sustainable fibers like flax, hemp, or plant-based fibers that in some cases are a very good substitute of the traditional fibers such as glass or carbon, introducing just a fraction of the carbon footprint that, for example, carbon has. Other topic is the end of life. We've seen, probably everybody has seen nowadays the graveyard of wind turbine blades that is expanding more and more in these years, because wind turbine blades are typically designed for a lifespan between 25 and 35 years. So we are now at the end of the first big cycle of manufacturing of wind turbine blades, and this is becoming a problem. It's a problem for blades, more visible, but it's been a problem for leisure boats as well in the past years. And so materials that have a more attractive end of life compared to glass fiber or carbon fiber are, of course, welcome and have to be looked at to me. And especially to young engineers or people studying engineering design, I always say that until now, we've been looking at stiffness, strength, weight, and cost, of course. Now we need to put sustainability into the equation. And sustainability means emissions in making the material, the raw material, in making the part, and also how to deal with the part once it's not usable anymore.
Fine. So that's quite elaborative. What are the present trends in innovation of these advanced composites? And if I may add, can you please talk about the different fabrics that you have developed and
Yeah,
the possibility of combining them with different resins, maybe thermoplastic or thermosetting, and the end-of-life options? So could you please elaborate and explain our attendees as to how you have gone about, how it has helped, and what prompted you to go for that?
absolutely. So at Bcomp, we are developing flax fiber-based fabrics. Our fabrics are 100% natural, so they are coming from a plant. So the same plant used to make our clothes, pretty much. Of course, the fiber is worked in a different way to get to the required strength and stiffness that is required by composite components, and also the fiber, we developed a way to extract the fiber so that it can be used in conjunction with the polymer, with the resin system, because that's our aim. So we're not coming from the garment industry, but whatever we do is tailored to the composite industry. Flax fiber have a very similar performance to glass fiber. So they are slightly stiffer and some percentage point weaker. But in a nutshell, we can say that if something has been designed to be built in glass, the switch to flax is pretty much a one-to-one. If instead we are comparing flax to carbon, there are some cases where we can be competitive also with carbon fiber. For example, car body panels, race car body panels, or supercar body panels. But that needs to be looked at more in detail and in a more elaborate way. The fiber itself and the fabrics can be combined to different polymers. The two big families are thermosetting and thermoplastic polymers. The choice between thermosetting, the usual epoxy, polyester or vinyl ester, or thermoplastic, typically polypropylene, is mainly driven by the performance we are willing to achieve, the mechanical performance we're willing to achieve, but also the volumes we are looking at. For example, in the automotive industry, we are talking about a yearly production of some tens of thousands of components, 50, 60 thousands of components per year. And this is, of course, not reachable using thermosetting resin systems. And this is why we worked on a combination of our fibers with polypropylene that can be heated in an oven and then pressed in a mold by a press. The typical time span required for the full process is in the region of some tens of seconds, so 60, 70, 80 seconds, depending on the complexity, on the size of the part. And this is, of course, not comparable to the minimum hours that are required in the thermosetting world. Of course, thermosetting resins offer slightly higher properties. So if we are looking at the top end of the properties, for example, in motorsports, we are looking at epoxy resin systems and pre-preg and autoclave. So this is to say that we are going back to what we mentioned in the beginning, that properties can be tailored and performance is not the only objective we are presented by our clients, but volumes is another objective. Cost, of course, is always, unfortunately, an objective. And therefore, we need to study the right combination between fiber and polymer to achieve what is required. Last but not least, you mentioned fire safety. Of course, being flax coming from a plant, the fiber itself is flammable. We've been now working for the last couple of years in the development of a treatment to make the fiber fire retardant. And we now achieved a very good level of fire retardancy that combined with fire retardant resins and, if required, by fire retardant gel coats, we can achieve the highest level HL3 in the new European standard for rail, for example. And we are working towards getting the approval of the same for commercial airplanes. This is something that we are working on right now, but the material is there. We are just moving now from the lab scale, let's say, impregnation to the industrial scale impregnation.
Very interesting, and our best wishes. Now,
Thank you.
a question that comes to my mind, that commercially, how is it different than the conventional fibers? Does it have any advantage?
I would say that from
Cost-wise,
the,
of course.
sorry, cost-wise?
Cost-wise, commercially.
Cost-wise, if you are comparing it with glass, these materials are more expensive compared to glass right now, and this is because we are at a different level of efficiency of the overall supply chain. So, plant-based fibers used for composite applications are relatively young. So we are talking about probably 5 to 10 years in an industrial scale. I mean. Whereas glass fiber has been there in the industry for possibly 60 to 70 years at industrial scale. So it's a different, we are at a different level of maturity and efficiency of the overall supply chain. And this is because we are young, basically. If instead you compare flax fibers to carbon, for example, we are cheaper. And as I said before, it depends on the application if flax is a suitable substitute of carbon or not.
Thank you, Paolo. Thank you very much. I'll come back to you
Thank
later.
you. Thank you.
Friends, thank you. We now move on to the next topic, which I have in mind, is the influence of evolving global market dynamics on demand of advanced composites. And for that, we have a very interesting panelist with us. May I invite Mr. Morad Montasir? Good afternoon, Morad. Welcome. Can you unmute yourself, please?
Yep. Hi. Thank you.
Yeah. Morad, please give us your views on market shifts that are shaping the demand for advanced composites,
The
whether
composite,
lightweight or
let's say,
yeah.
today we are playing in the global markets. As I can see the team here mostly focused from Europe, and this is. But when we talk about composite, really, it's a big competition come from China, of course. Nevertheless, US another big demand get is because in the past was to be a region where they produce and another region when the end user. Today, a little bit the equation changed drastically. Then and geopolitical situation and also what happened in the last event with COVID, the situation started to change. Then the demand also adjusts to the needs of the market. Saying that, we have a strong demand coming from Asia. This is include China, Japan, Korea, where really they're very demanding and high improving. Of course, Europe has been a big player. Then in this saying that I have a big R&D centers where the most of the technology it's getting developed and raised in the country, and nevertheless US another big market. This is was there, and the demand and the needs is always growing very fast. And the big question again is always I like to say where we're going, what next, where it's moving, where the demand composite basically, or we can agree, I hope it's based on the market. The market dictate the application, as we talk about aerospace, about automotive, racing, another satellite. All these really are the driven from our industry. Then we can be the best in our application, but there are no industry looking for it is useless. This is we saw it several times coming in the market. Then and we need to be carefully again what can happen from other side. And I like to say, and this one reason we move in this region, and I'm here based in Dubai in GCC, where the demand, the hunger for this technology is growing very fast. And let me say, GCC by their target, it's really looking to implement composite or high technology in massive way. Especially if you look what happened in this region in the last 20 years, is impressed in any industry. And compared with other regions where really they're very skeptic, or at the moment they're very slowing down, this region is growing very fast. And this is the beauty to be global. You can really adjust and tailor your solutions. Again, composite, play very well according to demand of each region. And this is again what happened or what works in China doesn't mean it to be the same in Europe or in GCC in this case.
So, in your opinion, the demand comes from which angle more? More, I would say. Maybe it is either the weight to strength ratio or corrosion resistance or lightweight, which you feel the demand is more.
Okay, let me answer. This is what the beauty. If you ask me, the demand from this region, I mean GCC again is corrosion. And in this region again, you are under the
Exactly.
sun.
Exactly.
It's 50, 60
Exactly.
degree most of the year. You have salt coming from the sea. You have sand from other side. Ultra V again, it's sunny all the time. Then if you focus what the demand in this region again is anti-corrosion material. And again, corrosion, it's a big problem. I can when I go to see some plant again in oil and gas offshore, really, it's you can see metal are become very weak. It's like butter. Let me say, in one season they need to replace valve, they need to replace pipe, and again going in crude oil is not easy to handle. Then again, composite material play a big role. Uh, Let me say here the point again, it's convince the market you have the right solutions. And this is again another expert with my colleagues we can share. It's create awareness, educate the market what composite and technology can help them and how can solve their problem. Then this is another expert, but if you go again, I assume in US another big you know uh, demand is come from aerospace aviation and more than anti-corrosion material. And this is again, each region really pull
Has a
the
different demand.
technology in one direction, and this is how again is the beauty.
Great. And in your opinion, what role do advanced composites play in supporting the durable and low maintenance infrastructure? And how does it help in low maintenance, higher
This is a good
durability,
question.
especially in emerging economics, where it is more important?
Yeah, this is the good question because I
Yeah,
see it coming here. The implementation compared to other regions is very fast, and one reason again is turnkey solutions ready. They don't need to,
mhm,
you know, play or create or invest too much in this application. Then having ready material and tested to qualify and tailor for the application for them is easy solutions. And one of the reason again, low maintenance. And in our expert usually we can guarantee better and longer the material lifespan than where initially maybe materials can be go for few years. Now we can go for 10, 15, 20, 25 years, and the technology help you to improve, and this is make it more sustainable, more safe, and more easy to implement for some industry.
I see. And I've read about your website and the innovations which you're trying to do. So, what manufacturing innovations are making the composites more affordable and widely accessible, as per your view?
Let's say I give you, no, as a CRP, we are focused really 90% on 3D printing, and this is started in 1996 in Italy with our chairman, and we were focusing really to do 3D printing when we understand that the market was demanding better material. Then this is where we create our segment. It's called WindForm, and this is help to tailor the industry. Initially, we start with one, two materials and was focused on carbon fiber reinforcer. As Paolo was saying, he used a long, chopstick. We are using short one. We diversify our portfolio because again, it's functional for our application 3D printing. And during the time, we start to grow with more composite material in our family. And again, this is come from industry. Just one of the latest, we are happy to say we achieved to have approval from NASA, JAXA, or ESA. It's to have satellites printed in our material, WindForm. And this was again long achievement because we have one of the high density and so on. This is help us really to be and to fix ourselves big achievements. And usually I like to say to the customer, if we manage to make satellite, I'm sure we can make a valve for oil and gas. But again, nevertheless, it's a matter of creating the right solutions for the right industry. Then today in the market we have almost 15 different materials, and really all of them they have different specs. Paolo again was mentioning about flame retardant. We have two materials flame retardant from the application. They got approval for interior design for aircraft and so on. And this again just to explain when you enter in these sectors to have a composite is unlimited, because each industry are looking for something different, and you can create one solutions to apply to all of them. It will be messy, and as in our case we are very small player compared to our big company, but we like to say we are focused again in 3D printing to, and our focus again starts from one parts to 1,000 parts, and this is again where make us
Coming to
strong.
that,
Yep.
yeah, coming to that, Murad, see, 3D printing is a very good concept, and just for the benefit of our attendees, who might not be very much aware, and
Yep.
that's how this 3D printing goes about. Can you tell us how this 3D printing has its advantage in making advanced composites? What is the advantage of 3D rather than the conventional system which we follow?
One of
For the
the okay,
attendees,
3D.
for the people who are new to this.
Okay, let me take one step back. 3D printing, really, the beauty it's come first of all from the design. Really, you can design anything come in your mind. The free design, the complexity become easy to everyone. And today I can say also the technology help a lot. We have artificial intelligence really simplify all this process very easily. You can take a picture of any item, and immediately you have the CAD file, and this is can be easily implemented in 3D printing. Then the next level, when you have the CAD data, the file, the 3D printing file, you need to print it. Then we have different technology, but in our case we use SLS, selective laser sintering. It's a powder-based technology, and saying that powder-based help you compared to other technology to really play with the material easily and fast. And you can have a basic polymer, can be PA11, PA12, or PA6, and you can make a recipe. Then you can make some little bit more carbon, little bit more glass bed, little bit more aluminum, little bit more. Then again, it's really make you become a small alchemist, where really you can sit in your kitchen, let me say, or in the laboratory, and you can play with material. I make it so easy, but the concept is really
Understood.
when you know the material and you have a good technology, in this case SLS, you can customize the material for your application. Then example, customer want a sealing material because it's going to be tank for the fuel. Then again, we have dedicated material, and we can really play and improve it. Or a customer want to improve the weight. Then again, we can put more carbon fiber, make it more light. Or again, we really play with the material. Usually, I use an example to make it easy. With the curry, maybe more people can eat. The curry is conventional over the world, but if you go in Pakistan, their curry is different from the one in India, from the one in maybe in the US, or the one you're buying from Italy. But why? Because your curry is more salty, my curry is more ginger, his curry is more cardamom. Like you see, you play with the recipe of the curry to make it suitable for your taste of
Okay,
your customer, and it's easy to understand more than what technology is doing.
correct,
I hope it's clear in
correct.
this way.
Yes, yes, it's quite clear. Thank you very much. Now, I have seen that you mentioned this wind foam materials. Can you slightly elaborate and tell how that helps?
Yeah,
You
this
did
was the
mention.
idea of our chairman, Mr. Franco Cipollini, because when we start, the company was based at 3D printing company, and he was the one to struggle on the material side. Like he didn't find the material good for his application. Then the idea, this is again back almost 30 years ago, why we don't play with the material instead of play with the technology. And he came up to create his own line of different materials being for. And this is again, it's go to create an easy solutions. As I mentioned, we do 3D printing, but it's our end solutions. We have customer who come and just take the material by themselves because they see the advantage, they see the potential. Then we keep our strength as a service provider with print part, but at the same time, big customer, big names worldwide, they are looking for materials. Really, we sit down with them and we understand, okay, what you're looking for, what you need, and we tailor the material for them. As I mentioned, at the moment we have 15 different materials, from materials suitable for racing, for aerospace, for automotive, for aircraft. All these help really, and one of the advantage again, as back to Corey, you can really make it accessible to everyone because it's easy to switch the format to your customer and not to change the taste of your customer to your industry. And knowing
Okay.
again, as mentioned, Asia or China or Europe or again US, really they have different demand, different expectation from our composite materials. Nevertheless, this has helped us in the last 20 years to have a lot of certification. I like to say our material is one of the most tested, skin
I
or
see.
about even outgassing when you go in again in interior design for train or for aircraft, or again skin proof when you go for medical application, and so on. We like really to push the boundary of our composite material to make sure fit in any application and to satisfy the customers.
Great. And lastly, for my interest, how does your company help in making advanced composites, and which industries have benefited with your expertise? You did mention something about the NASA, but which all industries do you mainly cater to?
Okay, good question. And the answer is a little bit more complex. Say, the company born in Modena, it's well known as Motor Valley. You have Ferrari, you
Okay.
have Maserati, you have Ducati, you have Dallara. I think my friends, I should call, they know the region, they know the industry, and everything immediately, the application was, automotive racing. And was easy because it's a common, but we start to grow, and slowly growing we start to receive more demand again. Just to make it short, in US, when we try to enter, really we failed because was no racing there. What was no culture about racing. Then we didn't manage, but immediately we switch in defense. Then, and it was a very good feedback from the market. Then one of the good industry we have in US in our composite material, again go for defense industry. We help them with and also in aerospace. Then coming in this region in GCC, where I'm at the moment, they don't have racing. Defense is very weak. We find a good application in oil and gas. Then because this is the main business in this region. And just to give you an idea, it's we tailor based on the region and based on the industry. Then it's very hard to tell you where our material is strong. If you ask me in Europe and Italy, yes, of course, is racing. If you ask me in US, there are no doubts. Defense is our main industry, generate 80% of the revenue. If you ask me here in Dubai, I tell you mostly is oil and gas. Then we have different solutions and different
Yes,
demand
yes,
from the
yes.
markets.
Now, when you mentioned automobile, it is near and dear to everyone because almost everybody drives an automobile. Can you tell us, if possible, which components of the automobile industry, may it be for racing or the conventional, you make, and how is it more advantageous than the other conventional ones? May it be
Okay.
the wheel, or may it be the
No, in we have
steering,
really
or
different aspects when we go, especially in 3D printing in this case, and it's a combination. Let's say it's two hands. You have one hand is composite, and second hand is 3D printing. Then combined together, we in especially in automobile in this region we have a big demand from classic cars because really there are. Just to give you an example, we had a new customer called 911. Their focus on doing maintenance only on Porsche 911. He has a big garage only in that cars, and as you can imagine, slowly there are no spare parts in the market. Then he's coming to me often for to print parts for him for his customers because imagine a customer with 20 years old car, he wants always to have it at the top, and it's very rare to find original parts. Then in 3D printing and in composite we are combining this together to offer him solution. Just give you an idea, but nevertheless, this region also in the car industry, there are few customers where they take the normal car and they like to upgrade. You will see a normal
yes,
patrol, and
yes,
they making it luxury. And again, they want better material. They want very light, strong. You will be amazed how many crazy things happen in this region in that industry. Then again, composite and 3D printing, it's a good fitting because they just come with an idea with a design and we're able to deliver it. And this is again just to give you some small example how we're helping, how we're working together in this region.
Thank you very much, Morad. Thank you very much for the valuable insights. Let's now move on to a topic which is very, very close to my heart. Having been associated with composite industries for 2.5 years, there's always been a problem of recycle and reuse, which has been a hot topic at least 20 years back when I used to move around in the fraternity. Now, of course, so many solutions have come through, and we are fortunate enough to have Dr. Pascal Gallo with us today. And good afternoon, Pascal. I would now invite you to share your thoughts. I've been told that there is over 40 million tons of composite worldwide that is expected by 2050 if we do not take any action now. Now, that 40 million tons of waste is a huge quantity. Uh, of course, governments are taking measures that they're asking people to do so many things. But therefore, the field at which you are working in has a great significance to the success and growth of the composite industry. Because if there is too much of waste, people are not going to go in for the composites. And so, to my mind, being an important factor for eco-sustainability and industrial growth, let us start with you, Doctor. For the benefit of our attendees, can you please explain briefly the concept of circular economy and its features? Because we keep on hearing about circular economy. So some people are confused at what does this circular economy mean? So can you please throw some light into it?
Thank you very much for hosting me. And it's true that there are so many definitions out there. I found a quote from Ellen MacArthur, which I think puts it in a nutshell. She said that circular economy is about designing a system that is restorative and regenerative by intention and design. So you have to have the intention and you have to design the system to make it circular. So basically, it's about eliminating waste and maximizing resource efficiency. So instead of the traditional take, make, dispose, which is a linear model, the circular economy focuses on keeping materials in use as long as possible. And you have strategies like reuse, of course, but, recycling, refurbishment, and remanufacturing. So I would say that key features would include design for durability and recyclability. So design, once again, actually. This allows for closed loop systems to retain the material value. And in turn, this minimizes the need for virgin resources extraction, which is very important. So you gain independence, you see, by doing so. And so, all in all, this makes you decouple the growth, economic growth, from environmental degradation. So this is what circular economy can be about, I would say.
Okay, great. And can you please also elaborate and share your experience in the strategy and also importance of advanced recycling and reuse of composite material for a circular and sustainable future? What sort of a strategy should be taken? What do you?
So first of all, actually, I think that in our case, what we did is we took a lot of time to listen to all the stakeholders to design a solution that it makes it beneficial to everyone across the value chain. And I'm insisting, actually, all the stakeholders should be involved. So we have companies or individuals generating the waste. You have the companies collecting the waste, then treating the waste, companies that refine the output products into reusable material, and finally companies that are manufacturing the new products to close the loop. So this requires a global understanding of the challenges and also the opportunities. And lots of exchanges. And this is why, I particularly appreciate events like this webinar, for sure. The other important aspect is to interact as much as possible with the authorities. So local authorities to, at least in our case, to get the necessary authorizations to operate. And then national or transnational, so European, in our case, authorities to adapt the laws and regulations to facilitate our activities. So, for instance, we need to interact with the authorities to, I can give you examples, like to export waste in view of valorizing it. And that's what we're doing right now with waste that are important to Switzerland that we treat, and we re-export the output material. This is made possible because there are laws that allow for that. Then I think it's important to interact with to establish standards and best practices, to homogenize the industry. I call this the commoditization of the output. So making the output a commodity to ease, the global transactions, and to make the output products very similar to products issued from virgin materials that were extracted from the earth. And then it's important to interact with the authorities to get financing as well. I believe that the economic model should not rely only on subsidies, but like any new initiative, and Paolo was talking about that as well. So, we're more expensive for sure. And these activities should be incentivized with dedicated financing.
Great. Can you please tell us, with your expertise, the current and emerging recycling technologies? There are various, okay, mechanical or maybe chemical, etc. So, can you please explain? That would be very interesting for all our attendees.
So I would say right now, when you want to dispose of the composite waste, you only have two options right now. So one is to burn it, you see, and the other is to landfill it. Now you have strategies actually to improve the way to dispose of the material. So, and currently, I think that mechanical grinding, this works mainly with thermoplastics, indeed, and it degrades the material, is a possibility. And then a basic thermal process involves the incineration in a cement kiln for co-processing. It recovers the energy, but destroys the material value. And now we have more elaborate schemes in the emerging technologies. So we are doing thermolysis, which is a low temperature pyrolysis, which is the fact to heat up the material without oxygen, you see, and in that way you depolymerize the plastic part, and basically you extract the fibers. So the plastic becomes pyrolysis oil, and you can take the fibers at the end of the process and to put them back on the market. Another interesting approach is solvolysis. So it's a combination of, I would say, thermal recycling, because it's usually done at around 300 degrees Celsius, and chemical recycling, because it involves solvents. It's very promising. So both technologies are very promising. I would say that these are the main technologies that are expected to provide the results which are necessary to recycle composites.
Thank you. Okay, so then in this recycling system, the reuse, the circular economy which we are talking about, how does the cross-functional partnership, cross-industrial partnership, help in achieving circular composite economy, to your mind, or how it has been helping?
So this is really key indeed. And I can give you, I'd say, the example of our own loop, you see. So we managed to establish partnerships really across the value chain. And so in particular, we're part of this consortium that allows for a full circularity on boat manufacturing. See, so let's take the example of the boats. We have Beneteau, which is the largest leisure boat manufacturer in the world, located in France, that is providing the waste. So it can be, mostly it's polyester and glass composites. But they also use, and I will go back to that, the helium resin, which is polymethyl methacrylate based, PMMA, like plexiglass basically. So they provide the waste. Then we, in the partnership, we have Veolia and Tangli, which is a local waste management company that is ensuring the logistics. So picking up the waste, sorting the waste, hosting our machines. So this is for the waste management part. Then we treat the composites, composite recycling as a company treats the composite waste. And then you have two loops, right? So you have a loop for the fibers. So there we involved Owen scorning. Before starting the webinar, they have this sustainer, and we source them with our recovered glass fibers. And we have down the chain Chomara, which is a prominent player as well, located in France, that is weaving the glass fibers into fabrics. So other loop, you have the plastic loop, right? So the plastic, as I said, becomes oil, and Arkema developed this sorry, helium resin that allows for about 80% recovery. So it's a thermoplastic. And then we have Total Energies for the polyester. You see, for carbon fibers, we need an intermediate company like Owen Corning, such as Lineat. And we're in a very good position to work with Gary on the topic. So overall, this loop provides a lot of traction, market traction for us. It helps us as well attracting investments and scaling up.
Great. I would like to invite Gary for your views on this recycling and reuse. You have been a veteran in this industry. So could you please give your views on this?
Yeah, sure. Thank you very much. And there's great understanding, Pascal, of where the situation is and where we both join. So fundamentally, what Pascal produces at the end of his process, we can then take and turn into a, should we say, a recycled UD material, which can be supplied much further up the supply chain than current non-wovens and felts that are on the marketplace. And I think just from the sustainability angle, yes, it's great we're producing a recycled, sustainable material, but more importantly, I think it boils down to that, what Paolo said, what Morad said, the economics have to stack up. So especially with carbon fiber, you've got an extremely expensive material. And just in the industrial processes of manufacturing goods, there can be up to 30 to 40% wastage in post-industrial. And that just ends up in landfill. So in a way, it's making more out of the virgin carbon fiber and resupplying it back into the supply chain. But our products, our materials can lie alongside Paolo's natural fibers as well. We retain normally about 70 to 80% of virgin properties. So the combination of our UD material and the natural fibers in some body panels, etc., where you need some localized stiffening, works really well. So you can actually have a fully sustainable material going forward. And our material fundamentally is an advanced paper making process. So when Pascal is finished taking the resins out of the end of life components or the post-industrial materials, we can then chop those fibers and normally we use between 3 and 10 millimeter fibers, and we realign them back into a UD material. So currently, most materials are non-woven or felt, as I said, but we can actually add to that specification and supply that into the marketplace.
Fine, thank you very much. And quickly to both of you, if you can, what are the properties of this recycled material, and how do they compare vis-a-vis the virgin material? Just quickly so
Well,
that.
sure. Yeah, as I mentioned, we retain really about 70 to 80% of the virgin carbon fiber properties. So we're about double that of glass fiber. And this is a really good key point actually, and I think it's not just specific for the carbon fiber, but it's also specific to the materials that Paolo produces. That you actually have some unique properties above and beyond the virgin material you're replacing. So, for instance, because we use between 3 and 10 millimeter fibers, our material is much more formable and drapable than current virgin UD. So it lends itself to be press formed, very similar to the operation that Paolo said in the body panel. So it's a high spec material.
Okay, great. Because why I was more interested is that most of the people, what they use is glass fiber and resin, okay, thermostatic resins. So the properties of the resins are important, the properties of the fiber is important. So the recycled resin, what sort of a properties would it retain, or does it need to be reworked?
So I can take this one. Indeed, actually, our strategy, take our collaboration with the Arkema, for instance. So Arkema developed this helium resin, so it's PMMA based. And when you do the thermolysis of PMMA, you recover 80%, give or take, of MMA, right? So it's the monomer itself. And it needs to be distillated somehow, purified. Same applies for polyester. And in polyester, the interesting molecules are benzene, styrene as well. And same here, actually, the strategy with the Total Energies is to purify. So all the individual molecules and to reformulate monomers and then pre-polymers.
Understood. Understood.
Um,
Thank you. Thank you. We now move on to running short of time. That's why I'm hurrying a bit. We move on to our next topic of the critical role of cross-country collaboration and research in advanced material technologies. Now, for that, let me first come to you, Paolo, first, if I may. What next generation composites? What are these next generation composites, and what are the key properties that make them valuable across multiple industries?
I think that the key property is, of course, sustainability, especially referred to what Bcomp is making, because, as I said before, this is a key, let's say, ingredient in the design nowadays, and needs to be a key ingredient in the design of any component, being it a laptop case, a car, an airplane, or whatever else. We cannot afford to design something for its use only, but the design needs to look at the full cycle of the component, which means also the end of life of the component, as Pascal was mentioning before. And this is, to me, the key point of sustainable materials. And by the way, we did some tests with the resin Pascal was referring to, so with the helium resin. And I think we got quite, I was honestly very surprised by the good results we have also for the end of life, how easy the polymer can be splitted from the fibers. And of course, looking at glass fiber or flax fiber, we have different ways of reusing or recycling or handling, let's say, the fibers at the end of life of the component, but still it's paramount to be able to separate the polymer phase from the fiber phase, and this is something we cannot neglect.
Great. Coming to you, Gary, what advice would you like to give the designers and engineers to change the way they design products to incorporate recycled fibers, including carbon fibers, because these engineers will have to redesign themselves to use this. So, what
I
advice would you
thought,
give?
yeah, I think actually it's down to the new material suppliers as well to understand that not all designers can change, especially when you've got very well matured processes like in the automotive industry. To think that somebody making cars is going to change their way they make cars because we come up with a new material isn't going to happen. So we have to be aware of that. But I think it's just being knowledgeable and understanding the new materials which are on the marketplace and how you can combine them. We work with sporting goods across all the different sectors, and there's different mentalities. Some people want to do 100% recycled product. Some people want to do a 50% recycled product. So it's where those key properties, as Paolo said at the very beginning, when you're designing something, if it is the ultimate weight and strength, then of course you're going to use virgin carbon fiber. But where there are other applications, then you should really look around at the materials available and combine them and have hybrid materials.
Okay.
If I may add something, I think this is a very important point, because often as designers we tend to focus on a monomaterial component, whereas we can easily combine flux with carbon with glass, and be able to fine tune the properties of the material according to the needs, which also has very big implications in the CO2 that the part has embedded, because we know that carbon has a GWP that it's huge. So we should try to limit it and avoid its use if it's not necessary. So all of this comes into the equation when we define the right material for the right product.
Very nice. Thank you so much. We'd now like to move on to the left out topic, and for that I would like to invite Paolo. That how does industry respond to the shifting regulations and consumer expectation with smarter, lighter, and more durable material solution? That is R&D collaboration and regulatory readiness. So my first question is, why are the R&D collaborations important in advancing sustainable solutions to composite materials? Why do you need to have R&D collaboration amongst industry?
We do need R&D because I think all of the players that are sitting around this table are working in a commercial environment. We are not university researchers only, which means that we need to have a market on the other side, because otherwise we can have the most sexy material we can find on Earth, but if there is no market for it, it doesn't make much sense. So R&D collaboration to me means R&D collaboration among all the companies working on a given project. Just to give you an example, we recently worked on an infrastructure project, a 60 meters long pedestrian bridge, 100% built in natural fibers. Of course, there are no rules for such a component, so we had to work together with the municipality. We had to work together with the designers. We had to work together with the labs that are testing our materials, the manufacturers, so that everybody was bringing to the project its own knowledge, and we can say make the others comfortable in moving ahead in this first project. Of course, this is the first one, so possibly the following ones will be easier to handle. But it's absolutely important that the R&D departments of all the stakeholders are working together to achieve the objective, especially when you are introducing in the market a new material, and especially if you're looking at very regulated markets like automotive, civil engineering, or aerospace, because as you can imagine, designing even a Formula One car or a racing boat has a very limited number of constraints. If instead we are talking about something that is carrying people from A to B flying, or has people walking on it like a bridge, the regulations are much stricter, luckily, I would say. But we need to show that we can comply to these regulations that are not always developed as much as the industry is developing.
So in that context, what strategies are industry adopting to align that? What do they try to do for that? Industries as such.
I mean, we personally are trying to show how the materials behave, showing real examples. So I'm not, of course, we need to test the materials at coupon level, but I think that a one-to-one demonstrator is a much more reliable example of a component that works. And the other point is that we have the luck of being involved in many different industries, so we benefit of some cross fertilization between different industries, which means that we can use the experience we make in automotive to show the aerospace industry that the materials are well proven and that they have consistent properties, or we can show the rail industry that we passed the aerospace regulation, so we are likely to be able to pass the rail as well. And I think this is, again, very important to benefit from other industries' experiences, but also benefiting from other processes and other materials experiences. So I think we need to have a very broad view of what's happening in the market and not focusing only on our little niche, because this is limiting our growth and our development.
Great. Now, I would like to ask all the speakers that if they would like to add on something from their side, which I might have missed up in any of the topics. Starting with you, Murad, would you like to add on something?
Oh, okay. I thought where the Gary was starts.
Okay. Now, Gary, go ahead, please.
I was just going to follow on from what Paolo said about R&D and collaboration. Now, I think that's the backbone of a startup company like ourselves. We've been going for 4 years, and if it wasn't for some of the collaboration and projects we did at the beginning, we wouldn't be in the position now. But definitely, as been mentioned before, they have to lead to commercial outcomes. I think the same goes for Bcomp as well. Early doors, we were speaking to the sporting companies who are wonderful at taking up new materials. There's minimal regulation legislation, so they'll try anything, very quick to turn around things. And that does follow on into the automotive, the motorsport, electronics, and etc. So yeah, I can only iterate what Paolo said about the R&D and collaboration. That's vital to understanding the materials.
So that's quite interesting. So with that, I think we can move on to the question and answer sessions, because I'm sure our attendees might be interested in gaining some experienced knowledge from the esteemed panelist. So let me try and read out some of them. There is one question that I have received, that when Paolo meant that the composites are tailor-made, does it mean that it is using the resin making like epoxy, thermosetting, thermoplastic, etc., or a post facto introduction for the desired mechanical properties? Not initially, but post facto. That is how I understand. If both, which method is preferred or popular?
So we can tune both the resin and the fabric itself. So the fabrics we make can have a different weave pattern, and this is done both from the aesthetical standpoint. So some clients are asking us to have a given weave pattern. Some very niche applications also ask us to have a weave pattern that is showing a logo, for example, a company logo in the fabric. Some others, for example, in the ski industry, are asking us, are giving us as a target a given weight and a given stiffness. And so we need to combine, for example, flax fiber with carbon fiber or glass fiber to achieve these results. And of course, the tailoring of the material can be done at a very fine level. It's again a matter of commercial viability. Of course, setting up a new material, it's a big effort in terms of time and resources and machinery required. So it needs to be backed up by a volume to be viable at a commercial level. And this is typically the approach we have, for example, for automotive interiors, where usually automotive OEMs have a given view of the car interiors in mind, and they ask us a fabric that is replying to their ideas and to their view of how the car should look like from the inside. And therefore, we can make custom fabrics with custom colors as well.
The second question I have for you is that looking at the possibilities of recycling as detailed by Pascal, I'm sorry, it's Pascal. Even though the life of these composites is encouraging, the challenge of the recycling is too high. This is true especially through epoxy thermosetting types. I hope good technological advances go hand in hand as time progresses. Your views, Pascal?
So our project started 5 years ago, and we started from blank page, and we had to calculate basically the amount of energy it would take to depolymerize through a thermal way, the thermosets in particular. And somehow, surprisingly, our calculations contradicted the literature. So, and at one point, when you go back to the physics of things, and you decide to take chances because actually you think that it's possible actually to depolymerize in the thermosets, in a thermal way. Then it's true that, of course, you feel the challenge, but after a small-scale unit operation, and that shows that basically, indeed, you can reverse the polymerization and with pyrolysis. Basically, you get the courage to move on to larger systems, and I agree that it feels very challenging somehow, but the results are surprisingly good. And I joined Paolo as well with the helium once again, actually, helium system. Of course, so you have two issues. One issue is the end of life, because the systems back then were not engineered to be recycled. So you really need to adapt, the process. I'm giving you one example, which is very, very challenging for us. It's the use of halogens, so chlorine, bromine, and fluorine as well. This creates acids in the pyrolysis system, and somehow you have to come up with built-in systems, to neutralize the halogens, neutralize the acids. It makes the process very challenging, but still it's feasible. And the contradiction is that it's becoming easier and easier because the industry is aware of the issue, and that the industry is adapting somehow their process and their material, to make the recyclability easier. And so there's a very strong message of hope somehow. It's challenging to treat the material that was manufactured 50 years ago. And it's I would say more challenging than recycling the materials which were produced by Bcomp, nowadays. So yes, to answer the question in a nutshell, it is challenging indeed to treat end of life waste, but it's feasible. And it's going to be easier and easier as we move on.
If I could just add to that as well, I think just another one of the problems that Pascal probably faces is, of course, it's great to recycle these end-of-life components and post-industrial waste, but if the process that's doing so increases the carbon footprint of the recycled product, then you're kind of starting back where you came from. So you can increase the carbon footprint of recycled carbon fiber significantly if you don't choose the right reclamation process.
Absolutely, Gary.
Great.
I fully agree. I fully agree, and I can give rough numbers, actually. Estimating numbers based on process. So let's say, taking into account all the CO2 sources. So when you do thermolysis, you have three sources: basically the energy that you use, the CO2 produced during the process itself, and then CO2 produced when you burn the output gases. All in all, actually, we considered that to recycle 1 kilogram of composite, take 50% glass, 50% polyester. But it doesn't change much actually with the composition. So it takes, so you emit about 400 grams of CO2. And this needs to be compared with the CO2 emitted when you produce virgin material, which is on average for the same material system 2 kilograms. So already actually you save a significant amount of CO2 with our process. And it's pretty similar. I think the numbers are pretty similar for sulfolysis. Just to illustrate actually what the guy was saying.
Great, great. Thank you. A quick question. We are running out of time. A question for you, Paolo. What is the mechanical performance of flax fiber composites compared to synthetic fiber composites? How do you compare it?
Yeah. So mechanical properties of flax fiber laminates are very similar to glass. It's an easy switch from glass. Whereas with carbon, I mentioned before the car body panels. Some of our clients are making car body panels for racing cars, like GT3 and GT4 cars, completely built with flax fibers and epoxy. And in that case, we can achieve the same strength, the same stiffness, and the same weight. So we don't compromise on the performance, of carbon, but with an 85% carbon footprint, lower carbon footprint. So it's a pretty big number. But this is the very sweet spot of the application of the material. And maybe another point that is often talked about is the mechanical properties through time, because of course flax fiber, like hemp, is a natural fiber and it's coming from a plant. So there is always the question about how consistent the properties are in different production in different years.
Exactly.
This was a challenge in the older times of the industry. Nowadays we put together quality checks and ways of manufacturing the yarn and therefore the fabrics that are limiting the variancy of properties, which is of course incredibly important when you're looking at programs that are running for multiple years, like automotive or aerospace. So you cannot have a set of properties today and a different set of properties in 1 year time. So, but this is nowadays something we understand and we can limit in a very efficient way.
Thanks. The attendee also is asking that, do you make jute fiber thermoplast prepeg, and how is the performance of jute thermoplast composites? This is the final question we will take, then I think we'll be running out of time. Go ahead, Paolo.
Sorry,
Do you make
you're
this
talking about
jute
jute?
fiber thermoplast prepegs?
No, we are not working on jute. We are working on flax only, not because we are opposed to other fibers, but because nowadays in Europe, flax is the fiber that overall has the best properties. So I'm talking about manufacturability, mechanical properties, cost, consistency in mechanical properties, and availability in the European market. At R&D level, we are looking at different natural fibers, but for now, flax is the fiber of choice of Bcomp.
Great. One quick question to Gary. It was in my mind. I forgot to ask you quickly. That is, what role would you like the government to play to make industry and business community to think, invest, and adapt circular economy?
I
Government
think
has to play a role, isn't it?
government definitely has to play a role. We're based in Wales. We recently moved from England to Wales for that reason. The Welsh government have invested in the company, looking at more circular economy, and there's a big push. And I think it does vary from government to government, but there definitely has to be a push. Otherwise, as we were having a discussion before the webinar started about people's take up of these materials is purely economics. You know, it has to be the right price. Otherwise, people don't take it if they have a choice. If they don't have a choice through legislation and regulation, then that opens opportunities for us all.
Right. Thank you very much. Thank you all. So, friends, as we come to the close of today's webinar, I would like to take a moment to sincerely thank all of you for your time, engagement, and thoughtful participation. I would also request all of you to mark your calendars for the upcoming third edition of Bcomp Expo from 7th to 9th of September 2025, and it will be held at the Dubai World Trade Center, and it's hosted by Media Fusion, who are also the hosts for today's webinar. Uh, the Bcomp Expo is the region's premier platform for knowledge sharing, industry dialogue, and it brings together individuals from the full composite value chain. Sorry, the attendees include suppliers, distributors, solution providers, and manufacturers who showcase the latest in composite manufacturing, product design, and material innovation. It's also attended by entrepreneurs and businessmen looking into investment opportunities in composites and advanced material for the region as well as exports, given the vibrant ecosystem available here for business provided by the governments of the region. So, I would also like to extend a heartfelt gratitude to our esteemed panelists for their time, insightful views, and information during the course of this webinar. Their contributions have been truly valuable and inspiring. And once again, a big thank you to all attendees for joining us, asking meaningful questions, and bringing your curiosity and attention to this important webinar. Goodbye and God bless. Over to you, Bhumi.
Thank you, Mr. Chatterjee. Thank you
Pleasure.
thank you to all the panelists and Mr. Chatterjee. This was truly a thought-provoking and a compelling discussion that we had today. I'm sure many in the audience will agree. The conversation brought much needed clarity and fresh perspective to a fast evolving and critical topic. We hope today's discussion sparked fresh ideas, practical takeaways, and a broader view of what's next of composites and advanced materials. If you would like to explore these conversations further, we invite you to join us in person at the third edition of the Middle East Composites and Advanced Materials Show in collaboration with the UAE Ministry of Energy and Infrastructure. So the dates are 15th to 17th of September at Dubai World Trade Center. Please mark your calendar and be present at the Dubai World Trade Center to connect with the composites and advanced materials industry. In case you are interested in participating and exhibiting at the event, please feel free to reach out to our colleague Monisha Nair. She will be the best person to guide you to exhibit and participate at our event. Our downloadable brochure has also been inserted into the handout section of your screen. Please feel free to download and please be present at the Dubai World Trade Center to be a part of this wonderful show. Thank you. Now that brings us to the end of today's discussion. A sincere thank you to our distinguished panelists and our moderator for sharing such valuable insights. Thank you once again for your time and participation. And until next time, stay inspired and stay connected. Thank you, everybody. Thank you.
Thank you. Bye-bye.
Bye-bye. Thank you so much, everybody. Thank you.
Thanks. Bye bye.
Thanks, everyone. Bye bye.